Hello, my name is Marcel Jung. I'm a team lead for M&E in North America, and I'd like to take you through the next demo, which I call Arnold Workflow 1, hopefully one of more to come. And the topics that I'd like to cover in this demo are listed here on this first slide. So the first two are end particles and MASH to build complex geometry very quickly. And what I'd like to build is a truss-based tubing system that will make up the ceiling to one of the hangars in the Dreadnought's content. I also want to use curve rendering as a way to render larger volumes of geometry quicker, as well as stand-ins to do the same. And then, of course, we'll also be talking about IES photometric lights, as well as a sky dome. And in the end, we'll add something like an atmospheric volume node to elevate the level of realism. So with that, let's go ahead and move to this next slide, where on the left you can see the idea of what I'm after, where we look at this tubular structure that's connected through these spherical nodes. And on the right, you can see what it looks like integrated into a scene. So here's our hangar, and the top is open. That's where we want to create that system. And in order for me to be able to create that, the easiest way would be to start with a piece of reference geometry, such as a basic box. And I elevated it in the middle to kind of break up the boxy kind of nature and the flat kind of ceiling that this would that would generate. So let's go ahead and move this in place roughly where I want it. And then I no longer need to look at the hanger. We can just essentially focus in on this piece of geometry and fill it with particles. So that's the first thing to do, is to jump into the effects menu and go to end particles and fill the object with, and if we reset this, we can set the resolution to 24 and fill that with particles. So let's look at that real quick. You can see how these particles are filling that box, and it gives me a decent resolution that I can use to base this truss-based system on. I no longer need the geometry. I do want to play this back to see if there's anything else connected to it, and you can see that the nucleus node is driving the motion. It has gravity associated with it and so on. So we want to delete that as well, so that we're left with just nothing but fixed particles. So the next step would be to attach a MASH node to it. And what's nice about MASH is that I can actually, through utilities, add a trails node to this particle system. And so when I do that, I don't want it to create trails because I have moving points or moving particles. I want it to actually connect each particle by a piece of geometry. So I'm going to set this to connect to nearest, and then as I dial up or down the max number of trails, you can see that there's more geometry being generated. So I'm going to set that max limit to something fairly high, like that, and then I want to increase the count to have the number of connections between individual particles increase. And so you can see that with a value of 8, we're actually getting something that is fairly representative of what I want to create. So this piece of geometry is great, but that's not really what I want to create. In the end, what I want to create is a tubular system that is connected with spherical nodes. So these are just flat faces that are extruded as a result of having a scaling value on the trails node. So for example, if I look at the trails node, you can see that there's a trail scale. It's just simply extruding from that base edge. So I essentially want to select all those base edges and then duplicate that into actual curves. So the way to do that would be to say, let's pick the geometry. Under modeling mode, we'll go into the UV editor and grab all these faces and normalize all these faces to 0 to 1 texture space. So normalize, open up the dialog, and we'll set this to each face as a separate object. So we'll go ahead and apply that. And once it's done, I can select the entire piece of geometry as an object and select all the edges that I need to duplicate into surface curves. So right click edge, and we'll grab all these left side edges, which are all the edges connecting this whole network of tubes. So these are all the edges that are connecting all the particles. So with that, let's go to curves and duplicate these surface curves, and it's going to take a while, but it is worth the investment. It's creating about 4,000 curves, and you can do this at a lower resolution. Of course, you can set the particle fill value to a lower resolution, not 24, but something below that. In this case, I want the complexity because in the final render, that's really what's going to look good. So Once this is done, these curves are starting to pop into the outliner, and what I'd like to do at this point, before I actually put them in what's called a curve collector, I want to get rid of the original trails geometry. So let's dump that. And then we'll select all these curves and put them, let's go ahead and drag this all the way down here and create a curve collector. So using a curve collector is really a new way of using sets. So in the past you had to create a set and then add custom attributes through the Arnold tab. Now you can see all these curves live inside of this curve collector, which has a bunch of attributes associated to the way these curves render. So what I'd like to do is set this to thick, which will render tubes, give it a width, and then we can also assign a shader so it shades and renders a certain way. In this case, I'll use the AI standard surface shader, the Arnold 5 shader. So right now all we have in the scene is a whole bunch of curves and some points, some particles. So we want to replace the particles with spheres. We've already set up our curves. Now we want to go ahead and duplicate or replicate geometry for these particle points. So let's create a sphere, and we'll do that again through mesh. And so in this case, I want to create a mesh network that is an instance network, and then connect this mesh network to my particles. So let's select the particles, let's select mesh, and then through the mesh utilities menu, I can connect end particles to mesh. So this is what we have right now, and we can select our sphere, original sphere that's hidden, and scale that down to maybe a scale of 0.06. And so now if I were to, let's say I wanted to see this, we can create a sky dome light, get a little closer, and render out an image of what we've created so far. And if my spheres are not big enough, we can just go back to our sphere and maybe increase the size of this just a little bit, like 1/100th of a unit, and get something just a tad bigger. I'm not really going to worry about the shader. I'm going to fix that problem in the stand-in. So once I've created a stand-in from this, which is really the next step. So the first thing I want to do is grab the hanger and expose it and say, okay, you can check the fit here if you wanted to, but this hanger needs to be turned into a stand-in. So I'm going to go to Arnold, stand-in, export, and I export this as an env.ass, Arnold source scene. So let's export that and overwrite that. And then the next thing I need is the node called curve collector and the node called mesh instancer. What's nice about this is I can select as many nodes as I need and export them as a single instance. And what's nice about this too is that it can be curve geometry. It can also be instance geometry. If you wanted to, you can go to duplicate special and instance geometry that way. That can be included and exported as a stand-in, or if you do it through mesh, which is what I did. And so in this case, let's go ahead and export this instance, and we'll go ahead and call this env truss underscore roof.ass. And also make sure that you export the bounding box. When you're replicating lots of stand-ins, you want to make sure that you don't have to, for each of those stand-ins, redraw and recalculate the bounding box as you're making copies. That actually does take up time. So let's go ahead and export this. And we're essentially done. As soon as it reports the result in the command line, you know that you can move on to the next step. And so if I get rid of all of everything that I had open, I can now just simply bring in stand-ins. So we'll create a stand-in that will load with a .ass file, which will be the environment. And if I wanted to actually see the environment, you could do that through the stand-in node by dropping down your viewport draw mode to something called shaded. You can also select something like a wireframe or the poly wire or something like a point cloud or something like a shaded poly wire. So once you get your reference geometry visible, you can see that there's quite a bit of aliasing on this, and we can actually fix that by turning on anti-aliasing, so that works on your stand-ins as well. And let's turn off the grid also. Under Arnold, let's go ahead and create another stand-in, and that stand-in will be my truss ceiling, if you will. If you still needed to go in and actually make adjustments in terms of where it sits, go ahead and just reposition this to exactly where I want it. And then maybe I want to go in and create something like a sky dome light, so we can render this in the context of the environment and not just the truss ceiling by itself. So let's go ahead and render that. So in this case, you could see that we get the illumination to come in and illuminate the environment, the hangar, quite nicely. I can also go into my sky dome and load a file texture that is an HDR that I'd like to open. So under source images, I have an HDR folder where I might want to find something like this curved hull. It has a lot of blue tones in it, and so as soon as I open that up, you can see that it starts to bring in that color temperature. And if I go back to my sky dome, I can crank it up to like an exposure of 2, for example. So we can use sky domes this way. We can also replace that sky dome with something like a photometric light. So unique light characteristics for lights can be specified through IES files, through photometric files. And so in this case, what I'd like to do is maybe get rid of that sky dome. And let's stop the render there for a second and create a photometric light. And there's that photometric light. I'm going to move this up above the truss ceiling and load an IES file. So up here I have a folder of IES profiles, and there's 30 there that all work. I also downloaded a whole bunch of them from like Philips and from like Ametrix or Lumiere, Metalux. They all have their own light profiles, .ies files that can be downloaded and used in 3D scenes like this. So the one I'm going to use here is number 23. So let's go ahead and load that. And as soon as I start up the render again, you'll see that nothing really shows up. And that's because we don't really have much of an exposure or light intensity. So I'm going to set the light intensity to something like 10 and maybe the exposure to something like 8. And now we actually get something to show up in the render. If we get a little closer, you can also see that the shadows that are being cast, because I have that IES light sitting above the truss ceiling, are very harsh and very black. And so if you wanted to fix that, you can select your photometric light and maybe lighten up the shadow color a bit, making it a little more transparent. But you can also go in here and fix the radius, for example. You can set this to like 0.3. You can see that we get much softer kind of rendering of the shadow across all your surfaces. There might be some noise in there, and so you would want to fix that through the sampling value in here. That's set to 1. You might want to crank that up to 2 or 3. And so this is unique for the light, whereas all the other sampling values for Arnold rendering can be found under Arnold Renderer. And you can see in this case we have this set to 3 and all 2s, the default values. And I'm going to drop this down a little bit more to speed that up even more. Okay, so once that's done, let's go ahead and make this shadow color a little bit lighter. I'm going to set the radius to 0, and that's really because I want to introduce something like an atmospheric light, and or an atmospheric node. Under environment, we can create under atmosphere an AI atmosphere volume node. And so once that's brought in, I'm going to crank this up just a little bit. And the reason why I set the radius on the lights to 0 is because when you have the radius set to 0 and it's a true point light, you're starting to see all these God rays in your scene, which are cast shadows through a volumetric effect like an atmosphere, as this truss system is just kind of generating these shadows. One of the things I might want to do is give this a little bit of a color temperature by just simply selecting a color like this, and then maybe go in here and increase the attenuation as well. So the attenuation isolates the atmospheric effect to where there is light intensity. So when it sees light intensity, it will actually maintain the same atmospheric density. Where it doesn't, it kind of drops it. And so it really emphasizes the God ray effect. You can see they're a little easier to see right now. Let's go ahead and maybe increase the density to like 0.02. And now I do want to go to my photometric effect and give it a little bit of a radius, like 0.2, to soften all of that up just a bit. The next thing I'd like to do is maybe change the material on the stand-in that we created. So let's pause this for a second, and I'm going to move up here and take a look at this truss ceiling. Render this out. Let's go ahead and restart the render. Let's turn on 3D manipulation. Let's get a little closer and drop the intensity of that exposure to maybe something like 4. So to assign shaders to stand-ins, you can override what the material is on that stand-in simply by assigning a new shader. So if we create a new shader, AI standard surface shader, and then select a preset, all of these presets ship with the software. And then below the double line right here are all presets that I've created. And so one of the ones that I've created is called silver. And if I select silver, you can see that now it generates this silverish looking metallic aluminum truss system. That's all good. Let's stop this and reposition the camera. I'd like to now copy this across so we have more than just one. So let's grab the stand-in, let's grab the IES node, and let's move it over so that they meet right there, and one more time. So now we have them covering pretty much the entire ceiling, as well as having a few more of these IES nodes. Let's move them over a little closer to the camera. So let's re-render this, restart up IPR, and you'll see that the intensity I dropped because of I wanted to actually get a close-up of that silver material on the truss system. So let's go ahead and increase the exposure on this to something like 5 or 6, up from 4, maybe 7, something like that. And you can see now we get a better coverage. We get more light in the scene, and we get a full coverage on the ceiling there. So that's kind of most of what the workflow is on generating a ceiling like this. Now I'd like to go in and maybe put these lights inside so we get an illumination that reflects off the ground and illuminates the ceiling that might look a little better. So let's go ahead and stop this render one more time and zoom out. We'll grab these 3 lights, move them below the truss system, truss ceiling if you will, and then move them over. We'll rotate this, let's say 40 degrees, and move this up just a little bit more, and then we'll duplicate them to the other side, roughly right there. We'll rotate this negative 40 degrees. And so right now I have all these lights pointing towards the center of this hanger, and we get something that looks a little more like this. Now let's zoom in a bit, get a little closer, push the camera into this scene as it renders. You can see these lights are a little too bright because I have twice the number of lights, and I have them also much closer to all these surfaces without casting any shadows through that truss ceiling. So I want to go ahead and select all of them and drop the intensity a bit by, let's say we'll make it 5 or 6, maybe 6. 5.5, something in between. This will work. So this is essentially how we can set up an environment like this, and maybe I want to drop the atmosphere a bit, but I do want to, or maybe not, I do want to add an element, kind of an object of interest like a jet. I have all these jets, these dreadnoughts jets, saved off as .as files, so we can simply create a stand-in, and then with that stand-in, let's go ahead and stop this real quick. So here are the .as files for the Eurojet, for the green jet, the prototype, and the red jet with the black stripes. I'm going to load the prototype. And so once that's loaded, we can move this up. I just need the volume. Maybe scale this down just a bit and rotate this towards the camera. And let's see how high this sits. Something like this. And then we can drop into a top view real quick and maybe move this towards the center of our scene. And then back to a perspective view where we can restart the render and get a sense of what that jet looks like in the environment. And so that's kind of how we can test and get the feedback to speed up the workflow and make creative decisions quickly. So as I let this render, you can see that it starts to bring in all the detail. The lights are essentially pointing down. There's no direct illumination really that occurs on this truss ceiling from these photometric lights. So the photometric lights are essentially shining down. Light is being bounced around and hits the ceiling to illuminate it and make it show up. And that's pretty much it. Thank you very much.